Okay, here are some things that you need before we can even get started in algebra, and that's symbols and sets of numbers. A few symbols that you need to know are, for example, the less than sign. On this problem, it says the expression 4 is less than 5. So some people think of it as the arrow points to the smaller number. So 4 is less than 5. It could also be read from right to left, 5 is greater than 4. This would be read 5 is greater than 4, or 4 is less than 5. The less than or greater than sign with a line underneath of it means less than or equal to or greater than or equal to. This particular one means less than or equal to. So this is read 4 is less than or equal to 5, and this is read 5 is greater than or equal to 4. You could read this right to left also and say 4 is less than or equal to 5. Then here's a not equal to sign. 5 does not equal 4. And here's an approximately equal to. That's an equals to with a little wavy line over. And so this is 16/3 is approximately equal to 5.33. It's actually equal to 5.3 bar. The bar over top of a decimal means that that decimal repeats. So it's 5.3333 going on forever right there. So a bar over a number means that it goes on forever. And so that's the symbols. And now let's talk about sets of numbers. The set of numbers, there we go. The sets of numbers that we're talking about is, first of all, the natural numbers, also known as the counting numbers, go 1, 2, 3, and so on. It does not include 0. Okay. Whole numbers do include 0. So 0, 1, 2, 3, and so on are your set of whole numbers. Your integers include all your positive counting numbers and also your negative counting numbers and 0. No fractions. No numbers that have to be written in the form of a fraction. So positive whole numbers, positive counting numbers, negative counting numbers, and 0. Let's go down here, scroll down a second. The next set is the set of rational numbers, and a rational number is any number that can be written in the form of a fraction, a over b, where b is not equal to 0. Let's see, for example, 4 is a rational number because 4 can be written in the form of a fraction. Negative 4 would also be a rational number because it can be written as negative 4 over 1. And 0 is also a fraction because it can be written as 0 over 1. Any number expressed as a terminating decimal, a decimal that does not continue, is a rational number. For example, 0.33. That's a rational number because that's the same as 33 over 100. If it was negative 0.33, that would be negative 33 over 100. That would still be a rational number. Any number that is a repeating decimal is also a rational number. For example, 0.7777, which we could just write 0.7 bar, meaning that the 7 goes on forever, can actually be written in the form of a fraction. It's actually equal to 7/9. If you take 9 and divide it into 7, it will give you a repeating decimal of 0.7. So all repeating decimals can be written in the form of a fraction. For example, 0.3 bar is 3/9 or 1/3. Just to give you another one, 0.72 bar would be the same as 72/99. 0.72 without the bar would be 72/100. Let's do a couple homework problems here. What sets do the following numbers belong to? Here's the first one, 1/2. Well, 1/2 is not a counting number or a natural number. Counting numbers and natural numbers are the same thing, and this is not one of those. It's not an integer, it's not a whole number, but it is a rational number. 1 3/4, same thing. It's just a rational number. Now, all numbers belong to the set of real numbers that we're dealing with here in this course. So these are also real numbers. The number -5 is not a natural number. It's not a whole number, but it is an integer, and it can also be written in the form of a fraction as -5 over 1, so it is also a rational number. 0 is not a counting number, but it is a whole number, it's an integer, and it's also a rational number. 0.3 is the same as 3/10, so it would just be a rational number. And 0.3 bar is actually 3/9, and any repeating decimal is a rational number. So that's all those two are there. And that will do it with the first video.